Hello, chat. What's up? How are you all? This is four. Day four of making a computer in Minecraft. So, let me just give you a quick tour of what I did uh, so far. Let me use my superior mode of transportation. So, this is a 4-bit ALU, and this is the same thing. So, last time I added flags to this. So now these flags this flag tells us if the output is negative and this flag tells us if the output is 0. That's all these flags do, and then this can do addition as well as subtraction. So that's really cool. And then all the way over there, hold on, I need to show you this as well. Let me show you the massive logo that I've built. Look at this. So yeah, I've put my world on planet Minecraft. So you know, Mambo Jumbo was telling on his videos that some people just steal his world download and then claim that it's their own world. Yeah, I did not want that scenario happening to my world, because that would just be a blatant theft. But anyways, now that the elephant in the room is out of the way, let me show you what I've built yesterday. So this is the RAM module that I was working on. Let me fast forward a little over there. I'll just pull to it. And I missed it, of course. So this is a working RAM module. Let me show you what it can do. So it can not only write data, but it can also read data now. So let's select the register at first position. It's at index 0. So this will be its address. Let's write 0 to it. So I've loaded 0 onto it. Now let me go to the other side while simultaneously connecting my third monitor, which I forgot to do. Alright, so here is the output. So it's saying 0 because we just loaded 0 onto it, right? And then if I go back to the first side, now what should I write to it? Let's write 2 to it. The humble number 2. I'm gonna write 2 on it. It's written, and look, it's outputting 2. Let's write 4 to the one to the third register. Yes, I finished the RAM module yesterday. I stayed awake till 2:30 a.m. in the night, and then the only bit I had was the yellow part over here and the purple part over here. I just did that off camera because that would have been really boring on stream. So yeah, now the RAM module is working and complete. So I have selected the number 2 here, which points to the third register since it's at index number 2. Now I've written the number 4 to it. Let me just write it to make sure. Okay, let me write 4 to it. I hope this isn't broken. No, it broke already. Wait, something's not right. You know what, I'm gonna debug this off camera because I know it's gonna be something really stupid. Like I spent a few hours debugging why the thingy wasn't working, and I realized it was because the signal strength is running out. Let me show you where the signal strength was running out. It's really goofy and really obvious. Look, there's repeaters right here, and then there's more repeaters right here, with just 4 blocks in the middle. Yeah, that That's suboptimal. So you know what the agenda is for today? Let me write it down without spilling stuff on my keyboard. Alright, so what we are gonna do today to do is where did the O go? This is an Apple Pencil noob, by the way. It's not even Apple. So we are gonna be making a program counter. Build program counter. So what the program counter does is that let me write it down. It essentially it is a counter for which instruction the computer is executing. Counts instructions. And so why do you want to count the instructions? So let's take an example of you doing something. Let's say you have to tie shoelaces. So in your brain you're gonna make an algorithm for it. So first you grab the left lace and then grab the right lace and then you put them together. Then you pull them, something like that. So each of these are discrete steps, right? They are steps 1, 2, 3, 4. The program counter is what keeps track of these steps. And now what we want the program counter to have, the functions that it should have, as in the inputs that it should have. Inputs. First should be increment. Increment. And then the second should be reset. And then the third should be load. LOD load? What's going on? Oh, because the blue line came, okay. Anyways. So what the yeah, these are the functions that the program counter should have. Increment basically increments its value by 1. That's obviously how it's going to be counting. Reset does what the name says, it takes it back to 0. And then what load does is that we can input our own value to it. So if we wanted to jump to another step, then we can have the program counter do that. So in Java or Python, you can simply just write a for loop or a while loop and the language will understand that. But in our extremely basic computer, we are gonna have to make the program counter jump. So it's gonna have to jump from one instruction to the other. Yeah, that's how it works. But yeah, it will make a lot of sense when it's done. So without any delay, let's start building the program counter. And I think I'll just use this register for it. Let me show you the things that I'm gonna be needing for this. So we have a 4-bit register over here. We can load 4-bit values onto it. And then this is the other thing that we're gonna need. This is a working incrementer. So I'm giving it a value of 0. It's giving me 1. I give it 1. It gives me 2. I give it 2. It gives me 3. You get the point, but let's give it 7. It's gonna give me 8. Let's do, this is 5. It's gonna give me 6. So yeah, this is a working incrementer. I feel like I can make it a tiny bit more compact though. I see wasted potential here. So I'm gonna build the incrementer once again. But for now I'm gonna clone this register. I'm gonna clone it right here maybe. Like so. There you go. Let me just clear its memory real quick. Alright, zeros, let's do all zeros. Alright, so let me let me brainstorm real quick. Let me use the iPad. So what should it be doing? If okay, let's use a different color and let's write in print. If reset not, let's write it in plain English. If reset is uh, if reset is 1, then it's gonna uh, set the program counter to 0. I'm gonna write PC for program counter, whereas if load is 1, it's gonna set program counter to x, where x is the input. And if increment is 1, it's gonna set program counter to whatever it's outputting plus 1. And then if none of these conditions meet, then it's gonna continue with the same output. Set program counter to program counter. What's with this over here? This is why you should use an Apple Pencil instead of whatever I have. So yeah, this is the logic that I'm gonna be following here. Why don't I... Okay, I should probably brainstorm this a little bit. So reset will be the input closest to the machine. Let's draw the logic right here using yellow pen because I might as well. This is our register. We have to input it something. This is in, and then why is it raining? Rain, stop the rain. What is that? Yeah, that's what I thought. Anyways, now that the weather is not bothering me, let's continue with this. So if in is true, and so what we have to do is that if reset is 1, then we have to make this in 0, right? So I believe I can just uh, use an AND gate for this. It ANDs with the not of our input, of the load input, not the reset, my bad. And then this goes into the register. This is what we are going to be storing into it. But then let's have a look at what in can be if the reset pin is let's continue with this. Let's try it again for the sake of clarity, a little larger this time. So here we have our data input, what we are going to be writing to this register. This is where our reset goes. But what data should we write? Let's have a look at this. So if the load is 1, then we have to set it to the input, whatever the user is inputting. Oh, I forgot this thing here. The NOT gate. This is the user's input. This is load. Okay. If load is 0, okay, if load is 0, then this portion is going to be 0. And then hopefully that doesn't write 0 onto our register. Yeah, hello. We got viewer in the chat. Raise. What's up? So if reset is 1, oh, hold on. I think this NOT gate might not be needed here. Let's have a look at this. If reset is 1, then it's gonna allow the user's input through. That isn't what we want, right? I think I'm gonna have to get rid of the NOT gate. That's how it's done. So if reset is 1, then it's gonna allow the user's input. Hold on. Okay, I think we did need the NOT gate. What was I thinking? Can this not be done using an AND gate though? That's the question. Chat, correct me if I'm wrong. So if reset is 1, then this line becomes 0 and it's feeding into an AND gate. So the user's input doesn't go through if reset is 1. If reset is 0, then the user's input can go right through. Alright, so far so good. Now let's worry about the increment. So this is the output of the machine, of the register. It's gonna go into an incrementer. And then that should feed right back into the machine, but not right now. We need some more logic in there. Let's have a look at the conditions. If increment is 1, okay, then we have to give it increment. Alright, so we can't add the user's input just yet. Yo, why is my screen flashing? Wait, never mind. Okay, so this is the input. This is increment's output. Now I want this to go through if increment is 1. Alright. Oh, otherwise, oh, I've just made a circular loop. This is not how it's done. If increment is also 0, where do I input the user's input then? Hold on, this is a slight problem. If all three are 0, then it's gonna continue by inputting what's already in here. Okay, yeah, I think I think I know. This same output should not go into increment. You know what? I actually have notes for this. Let me just open them real quick. Let me open them the notes for my own reference so that I don't accidentally do something wrong, because that would be awkward, right? So the input that's feeding, I'll just start with the new diagram because that's not a very clear diagram. So this is the number that we'll be writing to the RAM and to the register, I mean, and it's coming from a multiplexer. How do I draw that? Like this, multiplexer. And it's choosing, and yeah, as I said, it's choosing based on the reset input. And this input is actually coming from another multiplexer, which is choosing from among the increment and the user's input. Another multiplexer. This is based on the load signal. Wait a minute, this is uh just give me a second, guys. Yeah, this multiplexer, the first one is connected to false. I should have clarified that earlier. Let me just write 0 here. So if the user's input, so if users tells it to reset it, then it's gonna choose 0 over here. Otherwise, it's just gonna continue with this input. And then the other multiplexer here, it's gonna choose between increment and in. So this in is the user's input, and the increment, as I said, comes from an incrementer. Alright, and then yeah, that's the main part of it. And now let's have a look at the load signal for the register. So when will we tell the register to load something? This is actually really simple. If either the load, write, or increment, if either of these three inputs is 1, then we just write to the register. How easy is that? Okay, just the only question here is, where does the increment input go? Okay, yeah, here. Let me just draw a big OR gate. L R increment. Why can't I write anymore? Just like this. So if either load, reset, or increment is 1, then it's gonna send that signal right to the register. It's gonna tell it to write some new data, which does make sense, right? You want to load some data onto it, you want to write 0 to it, or you want to increment it. And then let's go through the logic to make sure that it all makes sense. First, the most important condition, reset. This gets precedence over everything before it. Yeah, if reset is 0, then it just chooses 0 for the input. It's gonna write 0 to the register. And then before that is load. So if load is 1, then it's gonna write user's input to it. Otherwise, it's just gonna write the incremented value. And if increment is also 0, then obviously nothing will be written to it because of this. Let's build it in Minecraft now, finally. After a half an hour of discussing how it's supposed to work. Alright, there it is. So here is the register. Now let's build the first multiplexer. And it's called a multiplexer, but essentially it's choosing between its value and reset. So let's see if we can get away with just AND gates. Let's see. Okay, let's make an AND gate like so. Okay, let's see. So where should I make the reset signal? Let's just make it roughly right here. And this is gonna be the reset signal for now. So if it is 1, then it's gonna allow the data to go through. That's the opposite of what I want. Let's try not. So when it's 1, it's not gonna allow any input to go through. Okay, that's exactly what we need. And actually, can I just optimize it right now? Oh, wait a minute. Will it even be possible? I don't want the signal to run from here onto this line. Uh, okay, no, I don't think this is possible. I'm just gonna have to place a torch here. Actually, is it? I can use the repeater. That's more efficient. Okay, good. I think we can just connect it like so. Here is our second input. Let's place a lever here. So our input should not be going through right now. And it isn't. Hold on, we aren't supposed to have a 1 here, are we? Oh wait, yeah, that's actually right. That's what we are supposed to have. Yo, we got yo in the chat. I make it look so easy. Well, computer science is actually genuinely really easy. I'm not even lying. Okay, so if I turn reset off, oh, now my signal can go through. Perfect. If I turn on reset, then my signal won't be able to go through. That's perfect. Now I just have to recreate this 3 more times. Easier said than done, but it's fine. Not that much. Let me make this right here, in fact. Can I make the torch here? Yeah. Yo. Oh, I'm the best Minecraft player you've seen in months. Very cool. Is that because you don't watch many Minecraft players? Because I'm genuinely terrible. Shout out me. Oh, shout out to you. Shout out, bro. How do I pronounce your name? Najid Muhammad. Y2G. Shout out. Shout out to bro. Okay, so this is a reset input. Let's make the exact same thing on the second input as well. Oh, hold on. Did I just make a torch tower unintentionally? Yeah, I placed this in the wrong place. Wow. Okay, now it's fine. Hopefully. Yeah. Okay, so 2 blocks gap is needed. Otherwise, I'll just make a torch tower. No problem. Free shout out for you. Let's go. Thanks for supporting the channel. I hope you have subscribed. This series is gonna be really cool in some time. We are literally gonna have a working computer inside of Minecraft. So it's in your best interest to subscribe, chat. But anyways, let's continue working on this thingy. Let's build a glass tower here. That would be efficient. I hope the input doesn't start running from this thing into the glass tower. That would be so irritating. But should go through. The reset is 1, so now they shouldn't go through. Yeah, all of these are receiving 0. Hold on. No, wait. I forgot to place the repeaters here. Okay, perfect. Yeah. Alright, so if I turn off reset, hopefully I should be able to write to this. Oh, hold on, I also need to turn on load. Okay, let's see if I can write stuff to it. Yeah, I am writing. The lamps are turning on. Wow, perfect. Nice. The last one also. Okay, it works. The reset input is working. Yeah, it is. Yeah, it does look really complicated, but it's generally simple. I think, uh, did I build this on live stream? Oh no, should I explain it right now? I think you weren't in the last stream, so let me explain it really quickly. So this is an RS NOR latch, and basically this is one logic gate and this is the other logic gate. I made them very small on purpose. But this torch is the output of the first logic gate and it feeds into the input of the second logic gate. And the second logic gate's output feeds into the input for the first logic gate. So this means that this thingy gets stuck in a state. But because this is part of a memory module, that's actually desirable. So right now the lamp is on. I can turn it off. But then the lamp will remember to be off. And then I can use the other input to turn the lamp back on. And then it will remember to stay on. And then a few more inputs on top of that. This is the clock input and this is the load input. And this is the in input which you saw. So I can write 0 to the lamp, I can write 1 to the lamp, and then this is the load input. So when I want to write something to the RAM, then I'll turn on the load and I can write to it. If I don't want to write something, I can turn off the load and now it won't write. The lamp will remember its state. And this is the clock because you remember RAM have clock speeds. So the clock signal goes 1010 and we want the RAM to only work when the clock signal is 1. That makes sure that all the components are on the same page. So yeah, this is the thing that I made. I stacked it up 4 times and the clock and load inputs are common for each of these 4 memory things. And yeah, I just, and yeah, where was here. So I'm working on that register right now. I've added the reset control to it. How do I, uh, let's mark it as complete. Yes, let's go. Now let's build the other multiplexer. The one for, the one which chooses between increment and load. Speaking of increment, should I get the incrementer done first? That would be the smarter choice. You know what, let's start building the multiplexer right now. Let's build it in yellow because color coding is underrated. I hate the people who build calculators using redstone. I despise those people. Okay, so here are the inputs. Yo, visuals by Nova was good. So now I have to build a multiplexer here. So I'm gonna be choosing between the increment and the user's input based on load. So we're gonna need to OR two AND gates together. This is gonna be the first AND gate. This will be the second one. Hopefully I don't regret this design choice. Wait a minute. Yeah, perfect. Torch goes here. Torch is here. These are two AND gates. Let's see. So this is where the increment will connect. This is where the user's input can connect, I guess. Or should I connect the incrementer here? Yeah, actually, that would be a better choice. So the incrementer can fit nicely behind this glass tower in this area, maybe. Hopefully, I can make it this compact. So this is where the incrementer's input will go. So if load is what will go here. You know what, I might as well turn these into target blocks. That's gonna save space. And look, redstone dust feeds into the target blocks. How cool is that? So over here we have users input and load, which is this one. If load is 0, then we have to select the incrementer. Can I just use a glass block here? Okay, I think so. So if I place a lever here for testing purposes, if input is gonna be 1, then it's not gonna allow this input to go through. So the incrementer will be here. Yeah, the incrementer, this torch never turns on if this lever is on. If the lever is off, then I can send data from here. Oh, can I? No, hold on. Wait, if the lever is off, then I can send data from the incrementer into a register. Uh, that what we intended when the load? Let's see, our first input. So our first input of this multiplexer is what will happen when the load is 0. And oh yeah, it works just fine. My bad. If this is 1, then we have to allow user's input to go through. So yeah, if load is 1, then we have to allow user's input to go through. That does make sense. Let's repeat this a few more times. Hold on, can I make this a little bit more compact? Actually, I can. Let's just make this a bit more compact. Maybe torch here. I can get rid of that input. We don't really need a lever in any of this. It's a computer, it's not gonna have levers inside it. Alright, so we need AND gates over there. Just like so. Oops. Okay, so the input that goes into here. Oh, I can make this a little bit more compact too. What do I want to? A glass tower over here can interfere with this input. So I might as well not. Okay, wait. I don't want this signal interfering with this one. So I'm just gonna build it a little away. That would be the smart choice, right? Let's build a glass tower right here. Oh, this works. Okay. I can get rid of this thing. This isn't the final design that I'm continuing with. I'm shifting it all one block inside. There's our, that's the torch, that's the repeater, redstone dust, torch here, and then, oh, by the way, chat, what's your favorite logic gate? My favorite logic gate is the XOR gate. What about you guys? Uh, okay, so, and then the rest of the input, let's make that as well. Okay, perfect. Hold on, the signal can't go from glass to the block below. Oh, but we have glass below as well. Alright, perfect. I really hope this works first try. I can't see my hotbar. This is a little disorientating. My phone is in the way because I'm reading the chat. If you tried, you're saying it would take you years to make this? Uh, well, it's actually quite easy. I mean, how do I say it? So if you understand computer science and you enjoy it, I genuinely don't think it's something difficult. I feel like an ordinary person could make this. I am an ordinary person as a matter of fact. Okay, a final gate. And a final input line. Alright, hopefully. Oh, I hope the signal strength isn't gonna run out. Let's place a repeater here. And then lever here. Let's see if the signal reaches all the way till the top. Why is the signal... Oh, I placed a solid block here, so the signal got cut. Wow. Alright, I think the signal does reach all the way till the top. Oh yes, it does. That's amazing. But I forgot to place torches on this side. There's not a single torch in here. Oh wow. I am amazing, thank you. Thanks for the compliment. Alright. So this is our load input. It should allow us to choose between these two inputs. This is gonna be the user's input. I might as well test it out if it's working. Just using levels for the moment. So load is 1 right now. I should be able to write. Oh yes, I can write to it. That's perfect. What? Why can't I write to it? You're eating mangoes? Oh, okay. Oh, you were eating mangoes. I thought that was out of context. Very cool. So your favorite logic gate is not gate combined with and. Nice. Oh, that actually makes a lot of sense. Oh, because the AND gate in Minecraft is made of NOT gates and an OR gate. That's actually a genius reply. Hold on, let me get rid of the green thing in the bottom left. Although it would probably have been gone by the time I fixed it. So anyways, why can't I write using this one? This should write to the register. This input is writing to the register. Then why isn't this one? Oh, because I forgot the target block here. Now it should be writing. Wow. Alright, let's see if I can write to every bit of the register. Yeah, I can. Very cool. Oh, let's see if. Let's test the other set of inputs as well. Let's see what the incrementer will do. So it's 0 right now. The incrementer can write 1 to it. The incrementer can write 2 to it. Actually, you know what? Let me test if I can still write anything to it. All of these inputs are 1. Let's set this to 0. Okay, so I cannot write anything when the incrementer is writing. What if I am writing something? Then of course I can write. Can the incrementer input write anything if I am writing something? Oh, you have one question, but I have to be honest. Yeah, what's the question? Oh, by the way, there's around 15 seconds of stream delay, plus there's a little bit of chat delay, and then there's more delay that YouTube imposes, so the questions might be a little delayed, but I think it's fine. We all have patience, right? We can build computers in Minecraft, we have patience. Alright, anyways, this is done as well. This multiplexer thing. Now I can start making the incrementer. Alright, now I'm gonna make the incrementer. Actually, I've already made the incrementer, but I'll have to make the incrementer again. Do I love doing Minecraft builds? Okay, so the thing is, I also play survival. If you want to see my forever world, I can show it, I guess. But yeah, I like building in survival. I like building houses. I like building other creative stuff. But I just like Redstone even more. I haven't played in my forever world in a few months, honestly. But yeah, I do. I like Redstone builds the most. That's what I like the most. So, anyways, let's have a look at the incrementer that I built. I have Instagram. Yes, of course, I have it at the rate FixoGenie. FixoGenie, should I type it out in the chat as well? Oh, it's the exact same thing as my username. I don't have to type it out. So is this, oh, this is not the incrementer, this is the incrementer, right? Where does this input go? Oh, that's because we don't need it. We only need the not inputs for this design. 4-bit incrementer, yes, that's what it says. And it does increment. Actually, let me show you the design. Let me show you how it works. So this is a glass tower, and you might have caught on to the fact that if you try sending power through a glass block, it can go over the glass block, but it cannot go down it. I hope that makes sense. Uh, Look, it can go over the glass block, but not down it. That's exactly the reason why signal can travel from the bottom throughout this glass tower to the top, but it can't travel downwards. So let me just do a 1 1 1 1. Now all of these are off. And so essentially, the logic of adding 1 to a number is that let's actually take a better number. Let's just take this. So you want to add 1 to it. What you will do is that obviously the least significant bit is 0. So you're gonna set it to 1. Now you've added 1 to it. But if the least significant bit is 1, then you can just set this to 0 and then set this one to 1. Now, how about this scenario where all your bits in the starting are 1s and then you have a 0 over here? So what you're gonna do is turn this to. So what you're gonna do is you're gonna start from the least significant bit and moving upwards, you will find the first bit which is a 0, and then you're gonna you're gonna do the knot of everything from the least significant bit to the first bit that was 0, just like so. Perfect. And then if you have something like this, you're gonna do the knot of the least significant bit all the way to the first 0. So these three have to be knotted. There you go. That's how simple it is. And that's exactly what I'm doing here. You can check my logic as well. Really extremely simple. So I'll just go ahead and build this out. Let me have a look at the logic. Alright, so not gates here. You know what? I'll build it as I go. I'll build as I go. Where was I? Here. So our input is this. Oh, I can just use this line. Right, can I? Can I use this line as the input? If this torch will be on, then this redstone line must be on as well. Yeah, so I can use this as the input. Very well then. Where do I place the torches? Right here. This will work. Is there a better way to take the knot of this input? Here, this would be more efficient, but in terms of packaging, this area is ready to use for the incrementer. Let's build it with blue. Actually, you know what? Let me just go ahead and take a quick reference once again. So here we have a glass tower which connects all the NOT inputs. Oh, and then we have an XOR gate with the input above it. Alright, this makes sense. Oh wait, this incrementer has a gap of 1 block in between the inputs. Okay. Should be able to manage. Hopefully. So now I need a glass tower. Like so. Alright, so now we have a signal going into the glass tower. And essentially what we want to do is...
Use mouse cursor or tab button to
No,
narrator.
not the narrator.
Use mouse narrator off.
Anyways, so here are the inputs that we want incremented. We have torches connected to them. Oh, but we also have torches not connected to them. Okay. Oh, that would be simple. I can just use repeaters. So I just have to XOR these, right? Should be simple enough. I think. Hopefully. Let's use blue concrete here. So this input here, here. Where should I place the XOR gate? What would be the perfect position for it? I don't think the perfect position exists, but I'll manage. like this. Oh, that's not how an XOR gate is made. What am I doing? I'm making the comparator uh using the I'll make an XOR gate using comparators. Just like so. This is our XOR gate. The panic after I turned on the narrator, that's so real. Because the narrator is it's like, yeah, it catches you off guard. Okay. And then oh, hold on, why am I XORing this with its own input? That's not what I wanted to do. We do not need this line. We actually have to XOR this with this one. I might as well place the repeater one down then. Because then I'll be lower than this torch level, hopefully. And that's our XOR gate done. Okay, so this torch will be able to send signal onto this block to the block below it. Oh, hold on. If I just replace this with a glass block, now this torch cannot send the signal onto this block, right? So this block won't be powered if I turn this torch on. Oh, perfect. That's great. So I can place the repeater here. And then this is gonna be a second XOR gate. In this case, this torch can... Oh, it cannot write data to this glass block again. Look, this redstone dust is off. Perfect. That's another XOR gate done. The last one now. We need repeater because the signal strength has to be maximum for these comparator based XOR gates to work. Okay. And then to power it. How can I do that? What? Have I messed something up? Oh, right. That makes sense. I have to place the repeater here. And then this has to be a glass block. So now the signal cannot travel down the signal column, but it certainly can go up. Okay, I think that's exactly what I want here. Let's see, is this all? Are the XOR gates just used as the output now? Yes, they are. Wow, it's that simple. Alright, let's just place redstone lamps here. And the knot of this is just used as the output for the first one, I think. Just like so. Alright, let's see if the incrementer is incrementing. Doesn't seem like it. There should be... All zeros. Why is the incrementer not incrementing then? Let's try doing the exact same thing in our working incrementer. All inputs should be 1. Okay. I guess I'll check my Instagram later today. I'll accept your message there. So 1111 should give 0, obviously. Oh, wait a minute. Oh, I have to feed the NOT of this into the XOR gates. That would make sense. Oh, that's actually easier to implement, I think. So this one is a signal strength of 15, right? Okay, no, hold on. Wait a minute. How do I implement this then? I was thinking I'll have a torch here, but wouldn't that break the XOR gate? Okay, the XOR gate isn't broken yet. Can I try breaking it? What? Okay, that's cool. Actually, you know what? This might actually be really easy. Hold on, let's see what the output for the first one is. Is it a knot of a knot or is it just the knot? Oh yeah, it is just the knot. Perfect. I overshot the pearl. Perfect. Alright, so the first output is working. Let's try the second one. We can't have a repeater here. Oh, this one is easy. Okay, we can just have a target block there. Hopefully the incrementer works. 1111 gets incremented to zeros because 1111 is -1 in binary. There you go, that's all zeros. If we increment all zeros, oh then that becomes 1, okay. If we increment a 1, that does not become 2. Oh hold on, all these are on, my bad. Okay, no it isn't working. Oh, because the load is on. What am I doing? Okay, so 0, 0, 0, 0. Yeah, thanks for spamming amazing in the chat. Wow, thanks. So 0, 0, 0, 0. 0, 0, 0, 0. When that gets incremented, it becomes 0, 0, 0, 1. If I turn this on, oh, it becomes 2, perfect. What happens to 2? It becomes 3. 3 becomes 4. 4 becomes 5. This becomes 6. 6, 7. And then this should become 8. Nice. What just happened here? Oh, I turned this off by mistake. Perfect. That's 9, 10, 11, yes, 12, 13, 14, and 15. Okay. And then here we have overflow. Okay, it's working amazing. Now I guess I just have to connect these inputs then. Okay. How do I do that? Will it be easier said than done, like everything in Redstone. Yeah, I feel like these XOR gates have a tendency to break. Yes, 6-7 in Minecraft, a comment suggested I do that. Okay, I'm gonna place the repeater here actually, so that way I have more freedom. Okay, perfect. This comes right into the input. Wow. Hopefully the signal strength wouldn't run out. No, no, it does. Oh, luckily we can just get the input from right here. We can steal the input from here. What have I just done? Oh, right. It's incrementing itself. So it's continuously trying to increment itself. That's actually funny to watch. Actually, let me place the torch here as well. Look at it go! Oh wow, wait. This is such a fancy binary counter. Oh, and it's actually kind of survival friendly too. I want this in my forever world. Why does the stream keep buffering? Let me increase my streaming bitrate right now. My internet provider will not approve of it, but YouTube will. That's what counts. Output 1400 kbps. What if I just double it? Actually, no, that would be absurd. 20,000 kbps. Okay, 14,000 to 20,000. How much does YouTube recommend? I don't know. If my internet service provider shows up at my door tomorrow, then I'll reduce the streaming bitrate. Alright. Wait a minute. Is it actually. Oh wow, it is counting. Albeit in a very frantic manner. Uh, how do I slow it down? I want to slow down the counter, not the game itself. I want to make sure that it's correct. 1, 2, 3, 4, 5, 6, 7, 8. I lost track, is it right? I have to make sure that it's correct. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, yeah, it is correct. Let's go. It's just that it's so fast and frantic that it's a little annoying. Let's just write all zeros to it right now. Perfect, there you go. Alright, so this bit is also complete. I'm glad to say that. This bit, I've circled it up. Someone's gonna take that out of context. There you go. So this bit is done. Let me actually also erase this random line, which I did not intend on drawing. So now I just have to give it the load, reset, and increment. Oh yeah, the slash tick speed, that's a really helpful command, but this thing is operating at its very limits, so I think that's where the problem was coming from. I couldn't count using these displays. I have trust the machine was working. It's just that the lights were flashing at the same time. So yeah. Anyways, now we just implement an AND gate for the load, reset, and increment. Can't be that hard, right? So this is the input for load. The one for increment is... Oh, I haven't made it yet. It's probably gonna be running through the underside of this. Yeah, the half of this is done. The second half is extremely simple. It's gonna be done in like 5 minutes. But first I'm gonna have to move this upwards. Are these the confines of the build? Yeah, I think they are. You can get rid of these glass blocks. They were intended for each of the 1-bit storage devices. We clone from here to here, over there. Over here, I guess. There you go. Oh, I did not have to destroy that. These are the bounding boxes. I'm keeping these glass blocks for when I want to clone this again and again. Okay. So here is our load input. Our other input... Oh, we don't have an increment input, so we just have the one for reset. Where do I get this? Where do I power this line? Do I just place a repeater right here maybe? And then I can soft power this block. Yeah, that sounds fine with me. Redstone dust all over here. How though? Can I... Alright, so redstone signal can go from there to there. Oh, but the redstone signal can also go from this reset input onto this line. Okay, how do I... Genuine question, how do I run the signal from here to here? Oh. No, bro has to go. Alright, I'll see you in the next stream, brother. Anyways, I'll continue here. So how do I power this thing? Let's place glass here. Why does it keep raining? Let me set it to thunderstorm and then it should clear up now. Let's see if I power it here. Does the signal reach all the way till the top? So it's supposed to reach that repeater. Oh, it does not. Short by 1 block. And there's nothing I can do about it other than place the repeater right here. Let's see how far it goes now. Oh, now it does reach the repeater. Alright. Oh, this has to be a solid block here. I can just power the repeater like so. Oh, this works. Okay, that's great. So this is a reset input. This is how we are gonna reset the thing. So it should be receiving all zeros right now. Yeah, it is. And then finally we have our increment input. Should we make it a little to the left? Let's also make the clock input right now. The clock input, let's make it out of magenta. Alright, let's turn it on. We can just assume that the clock is on. And then our last input. Oh, it fits perfectly in here. It's a increment input. All it does is that it feeds into an OR gate with the rest of these things. I can just get an input right from here. Oh wow, that's perfect. So I can take an input from this repeater, an input from this repeater. Oh. I can cut this bit off. Okay, so I'm taking an input from these two repeaters, merging them into one redstone line. And then the third one is just this. Alright. So this goes into the load input over here. Will this fit? Oh, there you go. That was perfect. Wow. So hopefully all of it should be done. Hopefully. Moment of truth. Oh wow, the input isn't even connected. Now, hopefully now it should work. Let me label the input for your convenience. Clock. This is increment. This is load. And this is reset. Alright, let's see if our program counter works. This is gonna be such a short stream if it works. I'm gonna start doing the debugging then if this works. Okay, so if I try writing something when the load, I try writing something now. Oh, okay. Oh wait, the clock was... Oh, I'm powering the clock by mistake. Oh, the clock needs to run from a block below here. Is this sufficient? I won't cut off the signal. Okay, perfect. You know what? I should solidify these connections right now. Oh. Small problem. How can I do that without cutting off this line? Can I run the inputs over here? Perchance. Or then I would also run them into this target block. Let's see. If I use a glass block here, or then our clock input will be able to power this. Oh, now I do it in Bedrock Edition. Actually, I think all of this will work in Bedrock Edition too. I believe the lamps have additional delay in Bedrock Edition, but that's just a display thing, it should still work. I'm not using a single piston, so all of this should work in Bedrock Edition as well. If you want, you can try it in Bedrock Edition. The world download is available from Planet Minecraft, but it's on Java, so you're gonna have to recreate it yourself. But anyways, let's try to not cut off the signal this time. Proceeds to cut off the signal immediately. This needs to be a target block. Alright, hold on. The big question. Where should these inputs go genuinely? Here? Yeah, that's actually fine. Okay. So I want these blocks to be powered for the inputs. Can I do the same for these inputs? I'll... Okay, why is this redstone connecting with this one? I do not want that. I can't even cut it off. Actually, I know what to do. Target blocks are such a game changer. What would redstone be without target blocks? Look at this, the signal is feeding straight into the target blocks. Wow. Why don't I make the first input in line with all these inputs? Wouldn't that look so cool? There you go, that's the first input. Second one's gonna appear right here, hopefully. Oh, this should be easy. There you go. Easier said than done as always. There you go, the signal is appearing over here. Alright, the last one. Actually, before that, let me play some music again. What should I play? Oh. Hopefully it works. Otherwise it will be so underwhelming. So here are the user's inputs. User inputs. Where's the music? Where'd the music go? I'm just gonna go straight to Epidemic Sound and play from there. Oh, the green box in the bottom left is back. Let me fix it real quick by unlocking my iPad on stream. Not recommended practice. Okay. Let's have a complete test. Let's try writing stuff onto it when the clock signal is off. I can't write to it. Turn on the clock signal and I just wrote to it. Let's stop writing. It should continuously hold its value now. Let's increment. Oh, we do not want this from happening. Oh no, we want the clock cycle to be involved. We don't want it to continuously... Yeah, it's stuck in a loop. Hold on. So the first... So the... how do I say it? Our first memory circuit should have a clock in it. Right? Stuff should only get written. Yo, hello. Yo, what's up? You said yo, Addy bro. Why are you calling me Addy bro? I am Addy and I'm bro. Okay. So I have to figure out why this is looping. It's constantly doing addition even though I don't want it to add stuff. I have to figure out the stuff. Okay, so this is based on the RS NOR latch. And then I have this thing over here. Okay, so if the clock signal is on, I can write stuff to it. Oh, but I would want the data to get written the next clock cycle. How do I do that? Instead of is there also a NAND latch? Okay, chat. I think the music is a tiny bit loud. Also, you meant Addy bro, but genuine question, why are you calling me Addy bro instead of FixoGenie? Okay. Let me try using a NAND gate. Okay. This will go into the input of the first gate, just like so. It's funny how I'm literally drawing gates in the ground. I find it funny. Torch here, and then now the other gate. I can have a line running on top of you. Oh, because of my Discord. You're saying Addy bro because of Discord? Interesting answer. Okay. Oh, is this the gate complete? I think so. So this is one of our inputs. This is the second input. Does that do anything? No. Wait. Oh, because NAND gate, I have made AND gates. Slight misinterpretation. Is that still doing anything at all? Does this remember the states? Oh wow, I don't even have a redstone line here. Okay, this can't remember its state. A NAND gate does not work, sadly. This is a NAND gate, right? Let me just do some rough work. A0 plus B0. Is that the same thing as a NAND gate? What's NAND? A dot B whole negation. Yeah, it is. So I was expecting this to get stuck. Oh, okay, I know you, let's go. I have no idea how to pronounce your name. I'll most definitely pronounce your name wrong. Let's go. Okay, so I want this gate to get stuck. How though? That's the question. Oops. Oh, I was so close to pressing Alt F4 by mistake. I was supposed to press Alt plus 3 to load these hotbar profiles. I wanted a torch. Let's try AND gates. Let's try knotting the outputs. Okay, wait. An iris knot, that should work. Now the question is, okay, so the way that this is supposed to work is that when I load some data, it's not supposed to get loaded immediately. It's supposed to get loaded next clock cycle. The question is, how do I do that? Is there even any way to implement this in Minecraft? Let me think. Hold on, let me draw a diagram of this. So we want the AND gates to get stuck somehow. Like this. This will be the input for set, this will be for reset. Let's say, suppose okay, wait a minute. Hold on, if I try NAND, will that genuinely work? So if both inputs are 1, then the output will be 0. If both, okay, let me try. Okay, I don't think I'm cooking here. This isn't remembering its data. What? How is that happening? I'm just gonna use an iris knowledge, I guess. Chat, the viewer count dropped. This thing is not working, it's not supposed to be doing that. Okay, so how do I make it output the data only on the next clock cycle? I think that's what the core component should be doing, right? The bit should be doing that. Okay, so we start with this 0. Obviously we're gonna want to load this. Chat, should I ask Gemini about this stuff? Or ChatGPT or Claude, whatever? Shouldn't this be working correctly? Isn't this literally what it's supposed to be doing right now? I have no idea. Oh, actually, what happens if I just turn off clock? That's gonna stop the entire thing, I know. Oh, hold on. Yeah, this is what I don't want happening. Oh, let me get rid of the green bar at the bottom left. Actually, I'll debug this a bit later. Right now, let's have a look at the other thing. Let's have a look at why we can't write data to this. So load is on, clock is on as well. I've selected the... This is selecting the third register. Oh, okay, let's see. That torch is on. This glass tower is also on. Hold on, I'm selecting the third register, right? 1, 2. So the register at index 2, 0, 1, 2. Yep. So this line is off. So the glass tower should not be receiving power, and yet it does. It's because it's receiving power from this thing. That's because of the stupidest reason. Wait a minute. It should be built like this. But then, how do I power the glass tower now? What? Have I built the glass tower in a different position in the other builds? Yes, I have. Oh, okay. Right, have I? Have I not? What? Oh no, the entire thing is wrong over here. I remember fixing this. Did I fix it in that build instead? No, must have fixed it for another register or something. What's this? It should be like this. Okay. Just like this. Is the glass tower able to supply power? Yes, I think so. But then what's gonna power the glass tower? The question still remains. Okay, I've powered it like this. Wait a minute, let's look at how I'm powering this glass tower. Okay. Like this. Okay, so one block below I'll place a glass. Where did it go? 0, 1, 2, this one. Alright, I get it now. And then this has to be powered by the repeater. Oh, this has to be a solid block over here. Okay, I think that should work. What's the output? I should be writing 4 to the register at index 2. What if I just disconnect the iPad? I'm not even using it right now. Problem solved. Let's try register 5. Oh, I accidentally wrote 4 to it as well. Let's write 5 to the register at position 4. Because why not? There you go. Let's write something to let's write 7 to the register at position 5 at index 4. Written to the register at position at index 6. I'm gonna write, let's write 6. Or what? Like this. Written. The one at index 6 gets 7. The last register gets an 8. Load. Alright, let's see what's written at register 6. Should be 7 written over there. Yeah, that is 7. Let's see what's written at the register after that. That's an 8. Let's try register 4. Is that what should be written to register 4? Yeah, 7. I think that's what I wrote. To the register at index 5, there's 6 written to it. Yeah, I think the RAM module is working. Okay, let's go. Now, the question is, should I just stack it a few times and turn it into a larger RAM module? What else do I have to make today? Is there anything else I haven't done for the day? Can we clone this 8 times? Is it viable to clone this memory segment 8 times? Actually, I'll think about the cloning later. First, I'm gonna clone this once to make a backup of it. Oh, I should genuinely get Lightmatica or some similar schematics mod. Let's clone this right here. Hold on, let's... Okay, it should get cloned where I want it to be. Oh. Interesting. Okay, I'm gonna have to clone it in segments. Hopefully I don't break it. There's a high chance I break this. Alright, like this. I hope the command works. I hope the Discord overlay doesn't get shared. Is this... I hope I haven't broken anything. Oh, Real Blue Dynamite in the chat, the goat. Let's go. Oh, we have Rick and Real Blue Dynamite in the chat. Wait, that's insane. Okay, but how will I clone this? So these are the X and Z coordinates. Am I just cloning air right now? Oh, I should start cloning the build any second now. Oh look, I am cloning it. Indeed. Layer by layer because the build is too big to be cloned at once. And then just 7 more times, I think. Oops. Nice. Finally, I think the build should be cloned. It's from... Oh, there you go. Perfect. Have I cloned absolutely all of the build? Yes, I have. Is all the redstone... Where's the redstone? No! All the redstone is gone. No. Wait a minute. This isn't good. I'll have to clone it again. Can't I just have a command block to this job for me? I think so. Oh. Oh. Oh, hold on. That's the command blocks, okay. Okay, hopefully I should be... no, redstone still isn't appearing. If I run the command manually. Oh, redstone is appearing. Then why can't the command block do it? Wait a minute. What's this the issue? Let's go! The redstone is here. Okay, I can destroy this now. Hopefully this RAM works as well. Let's write 2 to the register at... Let's write 2 to the register at index 5. Let's read the register at index 6. It's giving 7. That's exactly what I wrote to it. Let's try reading 5 now. I wrote 2 to it. Oh, let's go. It remembered that. Okay, so a working RAM module is working. Let's go. So now I think, can I just stack it 8 times? That would be so cool, right? The question is, should I stack it vertically or horizontally? If I do it horizontally, then the inputs are gonna be, yeah, it's gonna be easier to connect the inputs. With vertically, I'm gonna be having to run lines up and down. So let's just stack this horizontally. So that would be the agenda for tomorrow. Right now I have everything working. So why don't I do a quick world tour? Let me show you absolutely everything, including this FixoGenie sign that I've built. Look at this. So as I said at the start of the stream, I've uploaded my world to Planet Minecraft so that you all guys can also enjoy using my world. This is a pretty underrated resource to learn computer science. Not even kidding. I'm literally building a computer in here. And I've basically given my world my autograph because yeah, Mumbo Jumbo did not do that and people stole his world. So I don't want petty theft. Very honestly, that's the reason. This is a working 4-bit ALU and it also has these flags. This one tells if the answer is negative, this tells if the answer is 0. This is a working 16-bit ALU, my most impressive accomplishment so far. And this is another working 4-bit ALU. This is the adder, I believe, that the ALU is based on. That's the prototype for adder, I believe. This is also a 4-bit adder, but you can see how massive this is. This is the first real thing that I built in this world. This is also a 4-bit adder. Oh wait, it isn't, I think. This one was work in progress. Work in progress thingy. And then here we have the command blocks which set it to thunder when I hold a trident. Thunder because I want to fly using Riptide and also use channeling occasionally. And then when I switch to clock, it toggles between day and night. Where's the sun? And if I hold the clock, I can literally control the sky. So much aura. Yeah, that's about it. I guess I'll end the stream at that. So, tomorrow I'm genuinely gonna complete everything that I started today. Stay tuned for the series, subscribe to the channel, and I'll see you later, Genie.